Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 23rd of April. It is a Thursday and it is a day 1 in our rotation. So good morning, everybody. Hope you're all doing well today. Hope you're having a good Thursday. We're almost through another week of online learning. So yesterday, obviously, we had our Unit 2 Section 1 quiz. Last time I checked last night, I got about 78-ish responses on that. So hopefully we finished up and I have about 90 plus responses now and everybody got a chance to go through that and do that. Remember, the goal with that was not that you're perfect at the stuff, that you've learned something, that you've gained some knowledge about molecules and atoms and how everything fits together a little bit. And so the goal on that was to get above a 60% to pass. If you got above a 60%, I'll be releasing those scores later today, so you'll be able to see that. If you got a 15 or above, then you're good. You don't have to do anything. You passed it. It's out of your mind. That quiz should be out of your mind. But if you didn't get above a 60% for some reason, if you got below that, right below that, even a 14 out of 25 or like a 58%, I am going to ask you to take a makeup quiz. Now, I'll be honest, that makeup quiz isn't made yet. But what I need you to do for now is to start studying and start reviewing things that you might have gotten wrong there. What you might have messed up or what you might have not understood super well. And if you need to check in with me, send me an email, ask me questions, feel free to do that. But we will have to do a makeup quiz to make sure that you pass that standard, meet that standard, get at least that 60%. So I'll be in contact with you if you fall into that category. But check out your score today. I will post those sometime in the afternoon. So you can see those. So we're done with Unit 2, Section 1. We're moving on. Now we're on Unit 2, Section 2, right? So in Unit 2, Section 2, we're talking a lot about the 3D nature of molecules, right? How molecules actually take up space. And we have this lovely drawing of molecules, these lovely structural formulas that we've come up with and been drawing. And these are great. These tell us a lot about molecules. They tell us how much of each element there is in a specific molecule. It tells us how they connect, that carbon is forming 4 bonds to hydrogen and oxygen is forming 2 bonds, whether or not we have lone pairs on things which affect certain properties of a molecule. And these are great. But we're actually learning about the 3D structure of molecules now, how molecules actually look in 3 dimensions, how they take up space. You might say, Mr. Adam, how are we going to draw things in 3D on a flat piece of paper? That sounds very difficult unless I'm very artistic. Well, you're right. It's not easy. So instead of drawing things on paper, instead of drawing things on whiteboards, structural models, we have these things that we're going to talk about today. And these are called ball and stick models. When you watch Miss Marnick's video today, you're going to see that she's created some different models, and she's going to be still creating those in her upcoming videos. And I'll be creating some of them too to kind of look at different molecules and see what they look like, right? So in this ball and stick model, obviously we have balls and sticks, right? These balls represent different atoms, and the different colors represent different kinds of atoms, right? So these black spheres here represent carbon, these yellow spheres represent hydrogen, and these red ones represent oxygen. And we can see that they're all connected. We can see that this carbon has 4 bonds, right? Connects to 1, 2, 3 hydrogens, and it connects to 1 carbon. And this oxygen over here has 2 bonds. It connects to 1 hydrogen and 1 carbon. Now you're going to see that this forms a distinct shape. That if you look at just 1 carbon, right? Just this 1 carbon, you're going to see that those atoms bond around it in a certain way, that they're all far apart from each other as possible, right? So we're going to see that, and we're going to see that molecules like to form certain shapes based on how many things they're bonding to and what else they're bonding to. We're going to see how those shapes are created, okay? In our ball and stick models, you might see other ways for me to arrange it. I might use various different tools to make models, and then this one's my personal favorite, this little one. Looks like a little dog. But this is, again, showing that carbon is connecting to carbon, and that's connecting to 3 hydrogens on the outside, and then it's connecting to an oxygen that's connecting to hydrogen. So those 3 models that I just showed you are all the same, and they're all the same as this structural formula here, which is the molecular formula is C2H6OH. This is an alcohol because it's got an OH group, and this is actually ethanol. These 2 things are exactly the same as each other. It's just one is represented in 3D, and one shows the actual shape that a molecule would take based on what's connected to it and how it's connected together, right? So the big difference is this is showing things in 3D, and it's showing the shape that the molecule would actually take. Because remember, we perceive things in 3 dimensions. We see shapes all around us, and those shapes are made up of molecules, right? If you ever looked at, random thought, if you've ever looked at a crystal of salt, right? If you go to the Carnegie Museum of Natural History, they have big crystals of salt, halite, NaCl. You'll see that those crystals take on like a cube shape. And that's for a certain reason. That's because those molecules actually take on a cube shape. And so when you put a bunch of those formula units or molecules together, then you get that big cube square shape. So the shape of molecules is really important to us. It perceives how those molecules behave and how we see them in real life. Okay, so when we look at 3D shape, we're going to see that atoms are, like we said, 3-dimensional, and then they don't just bond in square shape patterns. So this molecule, this model, this representation, this structural model is fine, but molecules don't actually just look like square shape patterns where they have 90-degree angles between all their atoms, right? They actually look way different. They actually have this 3-dimensional shape. And like we said, shape is going to be really important for how a molecule behaves, and therefore it's going to be really important for how a molecule smells. Because remember, smell is just molecules interacting with our nose and then our brain. And so the shape of those molecules is going to have a lot to do with how they interact with our brain. And we're going to talk a little bit more about that. Tomorrow we'll talk a little bit more about specifically your review assignment, Smells Lesson 9 review. And we'll talk about how different molecules can have different shapes, even if they have the same functional group, right? Even if they have this OH on them right here, how does their shape potentially affect their smell? So we'll talk a little bit more about that tomorrow. I'll have more bigger molecules built for you, more specific things so you can see those and you can see what the difference in shapes is going to be for those. Okay? So go ahead and do the readings, watch the video today, do your best to start to figure out what different smells come from different shapes. But don't feel a need to do the review quite yet because we'll talk a little bit more about it tomorrow. Be familiar, getting familiar with your BallandStick models. Be looking at those 3D molecules and seeing how they're different from structural models, how they're different from the 2D models that we've been drawing. Okay? So we're going to keep talking about the 3D nature of molecules. It's going to be a good lesson. Just a brief note too. To make these, normally in class we'd be making these BallandStick models with these model kits, but you can actually make them on your own a little bit. If you have marshmallows, gumdrops, I'm trying to think what else. Marshmallows and gumdrops are good. And some sort of thing to connect them with, like toothpicks or pieces of spaghetti. You can kind of make these models on your own. And I'll actually send out a list that Mrs. Harris put together about what you can use to create those 3D models. So you can do that on your own a little bit since we don't have the model kits to play with in class. All right, gone on talking long enough. So for the share of the day today, what I'm wondering is, what do you actually like about this online world that we're in right now? So a lot of people are saying we're in an online world, we're doing things virtually. What do you actually like, or what have you actually appreciated about the online world, or the way in which you're able to connect with people online? I know when I've talked to some of you, you said you really like playing video games with your friends, maybe Fortnite or World of Warcraft or any of those things. Personally, for me, I'm hosting a Jackbox game night tonight. So Jackbox is these games that you play online and you play with your friends. So I'm really looking forward to that. I'm really looking forward to being able to play games and interact with my friends virtually and kind of have that opportunity to come together in a new way. So it should be fun. I'm looking forward to that. But what do you like about the online world? What opportunities have you taken advantage of to be able to connect with people online or do things online? What do you really like about this? That's all I got for you today. Like I said, tomorrow we'll have another video with different molecules that I'll talk about, different models. So I'm looking forward to that, and I will see you all tomorrow. Enjoy your day. Let's get a 1, 2, 3. Clap on me.